Hi, everyone. My name is Desiree Mackey, and this is my coworker, Brian. And this is our talk that we're calling The Crossroads of Civil 3D and Revit. So I'll give you a little bit of background of how we got here. So I'm a structural engineer. I've practiced in that space for a number of years. And so mostly for me, I've worked in Revit and within the building industry. And then I joined GEI 4 years ago. And GEI is an extremely diverse engineering company. We do all different sorts of projects. And then Brian joined GEI just a few months after me.
Yeah, and so my background is I'm a civil engineer. I did primarily grading, drainage, those sorts of things. Did that for about 8 years. After that, I joined the reseller channel, focusing primarily on Civil 3D, InfraWorks, other infrastructure products, and then did that for about 12 years. And now I'm here at GEI as the CAD manager.
And as we started teaching our coworkers Revit and Civil 3D, the question of which software do we use for which project started coming up more and more. So we found ourselves discussing which was the best platform for each thing. And so here we are. So we'll start with some Civil 3D examples.
Yeah, so Civil 3D, I'm sure everybody knows, is an infrastructure design program. So it's geared for grading, drainage, roadway design, infrastructure stuff in general. There's lots of different times when, Civil 3D is the answer. There's times when it's not, but we're going to focus on when it is the answer for now. So the first place is roadways. So roads, just about every project, unless it's strictly like a utility project, has some sort of a road to it, whether it's an access road for construction, an actual road that you're building, right? There's roads being used all over the place. And this is one of the areas where Civil 3D excels. Corridor models are what's used to model our roads, and well, that's what we do with them. So corridors don't necessarily have to be used for roads, though. I mean, they can be used for anything that has an alignment, which is the horizontal path, a profile, which is the elevations along the path, and then a typical section. So for a road, your alignment is the path of the road, your profile is the grades along the road, and your cross section is, hey, from the center line, we're going to go out, we're going to put in a lane, a curb and gutter, sidewalk, et cetera, et cetera. We can use these for other things as well. We can use them for swales, all right? So it's anything that has a path, an elevation along that path, and a cross section. Well, we can use a corridor for that. The swale, I'm sorry, go back real quick. The swale is a very simple one. It has the path, it has the cross section, and it's just a swale. We can use them for berms, stream restoration, all sorts of different things. Go ahead. Utilities. Utilities is another place where Civil 3D is really designed to work. Now, the utilities that we're going to be using are going to be more the underground utilities. So stormwater collection, sanitary sewer, water distribution, those types of utilities is where Civil 3D is going to be used. These are the underground utilities. Civil 3D doesn't work very well for like yard piping for like a treatment plant. Inside of a treatment facility itself, maybe not. Maybe the utility, maybe the pipes going between the buildings, we can model with Civil 3D. But within the building itself, you probably want to stay away from Civil 3D for those. But for the distribution, the site layout utilities, that's where you're going to be using Civil 3D for the utilities. Some things that might be a little bit less obvious. Here we've got this is actually a whitewater kayaking course. So the person that I was working with this was designing a kayak course and used a corridor model for the kayak course. Now there's some pros and cons to using a corridor for this. The nice thing about it is as you change your profile for the course, everything is dynamic and it all updates. This is one of those projects that we could probably do Revit, but in this case, because the person I was working with knew Civil 3D and had used corridors before, they decided to go with the corridor route. But this was actually the Olympic kayak course for the London Olympics, and so I got to have that much influence, just a tiny smidge of influence on the Olympics, which I think is kind of cool. And then finally, let's talk about walls. All right. So walls, these are things that could go either way. Now, Civil 3D does have corridor pieces, sub-assemblies that are geared for modeling walls. And these are typically going to be used in a transportation type of environment, right? We've got a retaining wall next to a road. And so we can attach a wall subassembly to our corridor model, and we can then model the road, the wall with it. And so over here on the left side of the screen, you can see several of the different wall subassemblies that we have. Now, if you look over there on the right-hand side of the screen, you can see that wall has, well, counterforts on it. If you need to model the counterforts, you're not going to be doing that with a corridor. Could we do it with a corridor? I suppose so, but man, that would be a lot of work because you'd have to assign different regions and assemblies for the different whether there's a counterfort there or there's not a counterfort, and it would just, this is not something that you would want to model in a corridor. If you're doing counterforts, or so it doesn't have this typical cross section, so you'd probably be better off using Revit. However, with Dynamo, we can actually add more things to our corridor using Dynamo. So with Dynamo, we can actually go in and say, hey, I've got this solid and I want to place this solid every so often within the corridor model to get the counterforts in there. So that is definitely something we can do in Civil 3D. However, I think Revit would probably be a much better place to do this than Civil 3D.
Right. And to create that graphic, we did use Revit because it was quick and simple, which is something pretty easily done in Revit, right?
Yeah, absolutely. This is definitely someplace where you'd want to be using Revit, in my opinion, at least.
Well, then that brings us to other places where Revit is really the better choice. So let's start with the obvious stuff. This is just a random screenshot from actually a training file that I use. So obviously not a real building, but anything building structures or actual buildings, things that you're using beams and columns and foundations. So that's an obvious choice, right? That's what Revit was originally created for, is these building structures. But if you expand that concept a little bit more, I've been using this term building type structures. So what you're seeing here is a couple of projects that we've done that were done in Revit that are clearly not buildings. These aren't buildings. They are structures, but they were modeled with building type elements. So in Revit, beams, columns, foundations, floors, these out of the box elements and tools that can just be put together in different geometries that are not a building, but are kind of like a building. So in the case on the left, it's an intake structure. And so the pieces were modeled using mostly beams and columns, but again, not a building, but building type. And then the right is a portion of a dam project that we did. So again, not a building. And this was a little bit more intricate. There was some slicing and cutting of some of the building type elements, the walls mostly, but made with out of the box Revit elements. So neither of these would be a real good candidate within Civil 3D. Right, Brian?
Yeah, absolutely. I would not want to try to model any of these with Civil 3D tools. They're just not, they just wouldn't fit.
Right. So the building type structures. The other term that, and we'll talk a little bit more about some of these structures later on in the presentation as well, but the other term that I've come to use as a good initial test of if Revit's a decent choice for a particular model is if the material is a man-made material. So in these cases, it's concrete. It's not soil or dirt, as I'm going to mess it up, I'm sure later. So it's enclosed geometric shapes of man-made material. So Revit's a really good option for anything that's like that. So then kind of going back to the walls, which is a bit of a gray area. Walls are really well dealt with in Revit. They have a lot of flexibility. So here, if you're doing 3D rebar, you're doing it in Revit. That's not something you're going to be going back into Civil 3D for. The other sort of gray area would be site walls, supportive excavation type structures. I'm showing secant piles here, but sheet piles would also be a good example. Those things could be done in either software, but Revit does handle those things pretty easily. And going back to that building type structure concept, the secant pile here on the screen, that can be easily modeled with foundations, columns, a couple of different options that are right out of the box, so are pretty easily done and might be a little bit more challenging in Civil 3D.
Yeah, in Civil 3D, in order to model that, well, you wouldn't. What we would do is we would draw circles where the secant piles are and then extrude those up and make solids out of those. In essence, we would be modeling this with AutoCAD, not Civil 3D.
Right. And so for elements like this, I like to think about what the basic shape is, because it's hard to think about using building tools for non-building structures. So if the basic shape mimics a column or a beam or a wall or floor or foundation that we have these out of the box tools for, we can pretty easily deal with that within Revit. And then one thing to point out here is in these cases where Revit can deal with these shapes pretty easily, that might be isolated little instances. One option that you have is go into Revit to create this wall with the rebar or whatever it is that you need, and just bring that 3D element back into Civil 3D if most of your scope is in Civil 3D. Okay, so that brings us to places where the two programs really do better in conjunction with one another. There's portions of the scope that are better in one or the other, and it just makes sense to use both. So we're using the term integrated project to discuss these sorts of projects where you're going to be a portion of the scope in Civil 3D, a portion in Revit, and there's a couple of things you have to decide as you go along the project. So there's a bunch of different types of projects that might fall into this category. Wastewater treatment plants are one. There's the building type structures would obviously be in Revit. Anything to do with the site and the grading, utilities, and other earthwork would clearly be in Civil 3D. Piping tends to be a little bit of a wild card. It can be done kind of in either place. So this example, what was done on the left, what's on the left was done in Revit. So you can see, again, these are building type elements. We've got floors and foundations and some piping in there that we went ahead and did in Revit. So that portion was done within Revit, and then that geometry was brought into Civil 3D, which you see on the right.
Yeah, and so in Civil 3D, one of the things that we always have to be aware of is that we work typically in a state plane coordinate system, at least here in the US. And our state plane coordinates are huge numbers. We're talking 1.5 million by 3 million for the coordinate values. And well, Revit just doesn't work well in those types of coordinates. So if we're needing to place this where the surveyors can actually get that information, well, we're going to be doing that in Civil 3D. So we can take the Revit model that's done in a very small coordinate system and bring it into Civil 3D, and so that the surveyors then can use that to calculate their stakeout points. The other thing that we use Civil 3D for in this case is the grading around the site. So can you do grading in Revit? I suppose so, if you really want to try to figure out all that topo stuff and edit points. Yeah, no, Civil 3D was built to do grading, so let's use Civil 3D to do the grading. It just works so much better. And it just use the right tool for the right task, basically.
You don't like the topography in Revit, Brian?
I'm not going to say I don't like it. I just would never use it. So dams is another place where it could be one or the other. So in this example, this is more of an earthen dam, right? So we're basically piling up a whole lot of, how'd you refer to it, Desiree? Oh yeah, that's right, dirt in this valley here. And we're building a dam. And so in this case, it's an earthen dam. And because it's got such a typical cross section, right? Remember the corridor model, right? You can go straight across, or the path in this case is straight across. The elevations along the path is constant, and then it's got a typical cross section, go out a little bit and then tie down into the existing ground. And so this particular piece was absolutely perfect for a corridor model or even the grading tools within Civil 3D. Now, you don't have to use the corridor to model just the exterior portion of the structure. I've created corridor models that created, shapes for the clay core inside of an earthen dam, for the cutoff walls within the dams, all sorts of different things. They're very, very versatile. It's not just the exterior shell. But in this case, definitely want to be using Civil 3D for a dam like this.
And then here's an example where Revit might play a role. So this is a project that we worked on where most of the project was done in Civil 3D, but this was an existing dam that we were primarily concerned with the changes of the geometry within the concrete structure itself. So quite a bit of this work was done in Revit. So how we created this is we had some existing data, we had some existing drawings, we had some site data, and essentially what we were able to create was XYZ location of the profiles along stations along the dam, if that makes sense. So what you see on the right are all the little purple points, that's the XYZ bits. And then we were able to create those cross sections, and using a relatively simple Dynamo script and the massing environment inside of Revit, we were able to create this shape that then we could bring into the project. And inside Revit, I want to say we did it a few times because we kept getting more and more accurate data. And then also when we did the new portion of the dam, we did it again. And the first time obviously took a little bit more, but I think that this whole process of getting those points, getting them in through Dynamo into Revit, into the massing environment, and creating this shape was something like an hour's worth of work. So it's a really efficient, simple process when you have something that looks like this. And Revit deals pretty well with, again, that's an enclosed geometric man-made blob of concrete. So that worked really well in this case.
Bridges is, again, one of those other things that you're probably going to have to be using both softwares for. In this picture here, this is actually InfraWorks, which is kind of the infrastructure side of things. So it kind of falls under the Civil 3D umbrella, so to speak. I'm not sure, right? But InfraWorks has the ability to model bridges, right? We can model, excuse me, we can model the piers, we can model the abutments, we can model the bridge decking, the girders, all of that stuff within InfraWorks, but it only gets you so far, right? If you're going to be doing the reinforcing of any of these components, yeah, InfraWorks does nothing like that. InfraWorks is great for this, getting you to a certain point, but after that point, you're going to be taking this off into Revit, where you're going to be doing all the detailed design, right? Now, the roadways themselves could be designed in Civil 3D, which would then be brought into InfraWorks to get you the initial portions of the bridge, and then you take that bridge and export it out into Revit.
Right, and you're not doing drawings or anything like that within InfraWorks as well. So you are eventually going into one or the other softwares, right?
Yeah, absolutely. InfraWorks does no documentations at all, so we'd have to transition it into another piece of software in order to do that documentation.
Right, and Revit does have a way to interchange. Did I just say interchange? Exchange and interact. It's those two words together with InfraWorks, which is a plugin that we're showing here. And so that's an option as well. So depending on where obviously you would do all of the grading and roads, like Brian said, within Civil 3D. So depending on what the scope of the project is, you might go one direction or the other. We worked on a bridge recently that was a little bit different as well, because the structure itself, the bridge itself, was very building-like. It literally looked like a floor frame. It had girders and beams and columns and things of that nature. So we just did the entire thing in Revit because of the scope of the work lended itself to those building type elements.
Yeah, and then once you're done modeling it in Revit, you can actually then take that bridge model back into InfraWorks or into Civil 3D for additional visualization purposes, modeling within Civil 3D. Maybe you want to see the bridge cross sections in your cross sections as well. So there is that interoperability between the programs for that.
Great point. Okay, so this next one was a really interesting project that we both worked on. And so this is a pier, and this pier is made up of these precast blocks they're giant. They're like 3 by 10 by 2 meters. So I used to say I was playing with Legos when I was working on this, but they were really big Legos. And the interesting part here is we actually did most of this project in 2D AutoCAD. The reason we brought it into a 3D environment was during construction, because we had some sequencing, and obviously with these giant blocks, some constructability coordination that we wanted to do ahead of time with the contractor. But it actually served as a really interesting comparison between the software and how we went about it to model these in 3D. And this is just a giant project. I had a hard time getting a good screenshot to see the whole thing, but you can kind of see how these blocks, thousands of blocks, went together. So I modeled this in Revit and used the information within Revit to create some construction sequencing. And I actually used Navisworks, which we haven't mentioned so far, for that portion. But the majority of the actual project was done in CAD, and Brian worked on that.
All right, and then we also used some Civil 3D for this project because there are utility trenches here. So imagine a big old ship pulling up to these piers, and this is where they're going to be serviced. So they're going to be refueled. They're going to have water brought on. They're going to have wastewater taken off, all sorts of different fluids type things. And so they have to pipe all of this stuff into this facility. So there are these giant trenches that had these pipes running in them. And so we were able to model that using a corridor model with the custom subassemblies that were created in Subassembly Composer. So with Subassembly Composer, you can create all sorts of really cool cross sections for your corridors. Now, in hindsight, that would probably have been better to have done in Revit than it was in Civil 3D, but the team that was working on this project at the time didn't know Revit at all, but they were very confident with corridor modelings. So we decided to go with corridors in that case.
Yeah, I sure would like to do a few more of these, but I think it's awfully unique just to see how we would do it again, given what we learned on this one.
Yeah, things definitely would have been done differently, but I think we still did a pretty good job on it.
Oh yeah, it was a sure fun project, and I definitely want to visit it. I don't think we ever will get to though. Okay, so our last example, we're using the term tunnel as sort of a catch-all. Essentially, anything that goes through another thing. And I know that's super complicated way for putting it, but
the technical term.
Yeah, very technical. But we're thinking of in this case, what you're seeing on the right is an actual tunnel, but we're thinking of things like irrigation channels, pipelines, aqueducts. Those sorts of things are sort of a gray area. So depending on the scope, we can and have used both software. So the one on the right this is actually a giant pipeline that the scope of work for us was actually understanding the health, for lack of a better term, of that pipeline. Is it moving, changing? Is it settling? Is it squishing? Another technical term. So what we did was we installed sensors, again, at essentially station points along the pipeline, and we used real-time data, which boils down to essentially XYZ with a time component of coordinates of the cross section of the pipeline. And then again, using Dynamo in somewhat a similar way as the dam that I showed a couple of minutes ago, is we were able to turn that data into cross sections and then quickly model that within Revit to see how the tunnel's changing. And it looks a little, in the screenshot, it looks a little like this red portion in the center there is maybe soil or something around it, but that's actually the profile, how it's changed over time. So we sort of overlaid original and like from now and then a month from now and so on. So that Revit worked really well to visualize data that you otherwise would have been looking at a spreadsheet. So not this deliverable wasn't a drawing like in a traditional fashion, but the 3D nature of Revit allowed us to pretty efficiently get some graphics for the reports.
Yeah, and as far as Civil 3D goes, we can absolutely model tunnels using Civil 3D. We can use it a corridor. If you think about it, your tunnel is a very consistent cross section as it goes through the hillside or whatever it's going through. So we can model corridors using that. The drawback to it is, though, is the typical output for corridors is surfaces. Now, one of the limitations of surfaces is that each point on a surface, each location, each unique XY value only gets one elevation. So you can't have a surface that represents the top and the bottom of the tunnel at the same time. So if you're trying to use surfaces for this, so our example, trying to get some volumes, those types of things, you'd have to have a surface that represents the top of the tunnel and then another one that represents the bottom of the tunnel. And then maybe a third one altogether that represents the existing ground. And yeah, so it can be done in Civil 3D. It can be done in Revit. This is one of those, like Desiree said, one of those gray areas where you really need to take a look at the project and determine ahead of time which one you think would be a better fit for this.
Right. And I think that often these sorts of structures would also include scope of work that would be the terrain around the structure, the thing going through the other thing.
Yeah, at the ends of the tunnels, the grading around those, that's definitely a Civil 3D.
Yeah, the other thing is probably the earth, which is definitely Civil 3D. So I think if you are using both, if something does lend itself better to being modeled in Revit, you're probably in the situation where you're bringing that 3D geometry back into Civil 3D from there. Okay, so that's a handful of projects that we've worked on and we've talked about which and where, and in some cases we've made the right decision, in some cases we want to do it different next time. But there's obviously challenges with this, right? It's not just a matter of throwing all this software on a computer and then everybody gets in the room and gets along. So there's challenges to be overcome. And I think the one that everybody's probably thinking about that's the most important is how do you exchange the geometry, the data, and how do you, if your deliverable is traditional drawings, how are you creating those, especially if you're in two different pieces of software? So we focused a lot on where to create the 3D geometry, which I think is really important because that's what you're going to create your documents from. But then how do you create the documents? So in some of the cases, if you have separate geometry in the two different software and the scope of the different pieces of work are effectively separated such that you wouldn't share sheets, you could potentially create your documents, create your Revit sheets in Revit, create your Civil 3D sheets in Civil 3D, and then combine them later on in your PDF software or something like that. Where it gets a little bit more complicated is if the scope is integrated. So the control structures that are going in the grading or the tunnels that we just talked about. So in that case, you are looking at exchanging the 3D geometry back and forth. And our suggestion is, where's the lion's share of the scope of work, right? Is it predominantly a Civil 3D project that you're dealing with grading and things of that nature, and you just want to take this one piece of Revit structure and put it into Civil 3D? If that's the case, do all your drawings in Civil 3D, and then vice versa, right? If you are just representing some grading or some site information and you're bringing that into Revit, keep your sheets in Revit. And then the challenge here when you're exchanging 3D data is getting it to come into the right place. And that's a really big conversation that we're always having, is how do we make it come in automatically in the right place?
Yeah, and so one of the tools that we have available for that is the shared reference point. So the shared reference point allows you to work in Civil 3D, identify the coordinate system in Civil 3D, export out a file that you can then bring into Revit and create a new coordinate system, so to speak, in Revit that matches what you have in Civil 3D. So when you link in a CAD file into Revit, it just comes into the right location. When you export a drawing out of Revit and you bring it into the Civil 3D drawing, it just comes in at the right location. It's a little bit of setup ahead of time, but it's so worth it in the long run because it makes life so much easier when you're trying to share the data back and forth.
And there are ways to get there without using this add-in. But in Brian says, it does take a couple of steps and a little setup ahead of time, but it's a little bit more consistent and reliable. I found that if you do it without this, while doable, sometimes it doesn't work as well as you expect it to. So if you haven't given this add-in a try, definitely do so.
And one of the drawbacks to it is, for those that are using Revit, is you're relying on the folks that are using Civil 3D to give you data to do this. And so if you don't have somebody that's competent in Civil 3D to do that, then you're probably going to have to do this on your own.
There's also a units gotcha. Make sure in the consistent units in both software. Okay, so there's definitely pros and cons to the two different pieces of software, and in particular with the integrated projects, where you go and how you do it. And if you're choosing to use both, the strengths of each software, I think, is compelling enough to work through those challenges. And we certainly haven't learned everything about this along the way in the last several years working at GEI and solving these questions, but we've started to learn a little bit more, and look forward to trying some more project types to see what else we can learn. Anything to add, Brian?
No, I think that about it does it.
All right. Well, thanks for joining us.